The harvest season is approaching in the villages, and farmers are busy building watchtowers to guard their fields. Ramu is erecting one in his own field too. At that moment, the neighboring farmer Bhima spotted his tower.
Hey Ramu, everyone else's towers stand on just 4 poles. Why are you adding extra ones like designing a car frame? That buffalo Bablu is crazy. What if it smashes our tower? That's why I'm reinforcing it. By putting this extra pole in the middle, the tower will be much sturdier. I've seen bridges and towers built like this in many places, so I thought I'd do the same. Seeing is believing. They agreed once they saw it. It's not just for show. I've used some brains. When the load's force is spread over more poles, the tower won't break. If weight is the issue, use thick poles like mine. Thin poles won't help at all.
Engineer Ramu proudly built his tower, and the two began their watch. At midnight, a noise goonj. Bagba diya bichum. Seems that crazy Bablu has arrived. Then what we feared happened. Bablu the buffalo charged and completely toppled Bhima's entire tower. Bhima somehow fled and climbed up Ramu's tower. Bablu followed, but Ramu's tower absorbed the impact and both stayed safe.
I did say this tower wouldn't break, but look, Ramu, one of our tower's poles snapped. Otherwise, how else could it have fallen? It's all about the tower's structure.
If you apply a force to a structure, its sides try to deform. And due to this deformation, the structure's joints and beams, which are made of wood, respond. They generate an opposing force. And as long as the applied force isn't sufficient to fracture any structural joint or supporting beam, the overall framework of the structure remains stable. Among all geometric shapes, the triangle provides the most stable structure. Let's see this with an example. Take sides of fixed length and join them to form a triangle and a square. With fixed length sides, you can form only one triangle, but the square can also shift into a rhombus, meaning multiple quadrilateral shapes are possible. If you attempt to deform the triangle, you experience an opposing force along each of its sides, meaning even if the joints are free to move, they resist any displacement. Even under substantial pressure, the triangular structure cannot change shape without fracturing one of its sides, which means its overall strength directly depends on the wood. With a square, that's not the case. If an external force makes its joints go loose, it can deform into a parallelogram or rhombus without changing side lengths. It will then easily collapse. This means the structure's strength here depends not on the wood, but solely on the joints' strength, which is much weaker.
Wow, Ramu, when did you study so much? Not that much, but I've got a great eye for observation.